All right, here is the second free response problem in the Unit 5 review packet. So we have R, it says it's a shaded region, but it's basically this region here. And it's bounded by the square root of x above, below e to the negative 3x, and to the right, the line, vertical line, x equals 1. And they want us to find the area of R. So for that one, what we have to do is integrate top curve, which is the square root of x, minus bottom curve, which is e to the negative 3x, dx. And we know that the right-hand limit of integration is 1. We do not know the left-hand limit of integration. We're actually going to have to find it. So the way that we're going to do that is graph both of these equations. So in my y1, I'm going to put in the square root of x. Oops. Goodness. Okay, go back to y equals, and I want to type in the square root, there we go, the square root of x, and then under y4, I'm going to type in e to the negative 3x. E to the negative 3x. So now when I look at my graph, and I'll do a basic zoom 6, I think that'll be just fine here. So there's the square root of x, here's e to the negative 3x. You know what, I'm going to zoom in. I don't see it well enough. Let's just zoom in on the origin, and that will hopefully be enough. Okay, I need this intersection point right here as my lower limit of integration. So I'm going to go to second calc. Choice 5 is intersect. Curve 1, curve 2, guess. And I find that that intersection point is 0.2387. 0.2387. So now what I'm going to do is I'm going to integrate from 0.2387 to 1, and I'm going to do alpha f2, choice 4, oops, you know what, I need to be on my home screen to do this, so let's go back to the home screen, alpha f2, choice 4, and I'm going to go from 0.2387 up through 1, and I need y1 minus y4. That's how I had them set up in my y equals screen. So I'm going to go to vars, y-vars, function y1, minus vars, y-vars, function y4. And then, of course, I'm going to integrate with respect to x, and it's going to give me the answer 0.4426. Okay. So the next thing that I'm going to do is part B, which says find the volume generated when we revolve around the horizontal line y equals 1. Horizontal line is up here. And let's just, actually I can confirm right away, since this is the square root of x right here, the square root of 1 is 1. So I know that I can take, that this basic intersection point is goes through this point right here. That line goes through this point right here. So I'm going to erase some of that to make it look easier to see. And I'm going to put that's my axis of revolution right there. So now what I need is, I need big R and little r. Big R is right here, and little r is right here. So let's write those out. I have big R, and I have little r. So the first thing I'm going to do is my big R is going to be top curve minus bottom curve for this length right here. Top curve is 1. Bottom curve is e to the negative 3x. And then for my little r, I again have top curve of 1 minus bottom curve, which this time is x squared. Or I'm sorry, square root of x. Then my integral, when I revolve around the line y equals 1, I'm going to have that same lower limit of integration, 0.2387, same upper limit of integration. This time I have 1 minus e to the negative 3x, all squared for my big R squared, and then 1 minus the square root of x, all squared, for my little r squared. So now I'm going to have to do some work within my calculator to get it to the point where I can integrate this. And I think my approach is going to be to go back to my home screen, and I think I'm going to work on my little r here and just insert a 1 minus, and then actually insert parentheses. So I have 1 minus rad x, and then I'm going to square it. So that is my little r squared. And then down here, I'm going to insert open parentheses, and then 1 minus e to the negative 3x, close parentheses, and square it. So now my big R squared is in y4, and my little r squared is in y1. So now I'll hit enter, go back to my home screen. I'm going to start, by the way, I didn't put in my pi here. This is a volume by revolution, so I do need my pi. This is my whole equation. So I'm going to start with a pi, and then I'm going to multiply by, and I'm going to go to alpha f2, choice 4 for the integral. 0.2387 is my lower limit. 1 is my upper limit. And then I'm going to do y4 minus y1. So vars, y-vars, function, y4 minus vars, y-vars, function, y1. And then I'll come over here and make sure I'm integrating with respect to x. And I'm going to get that my answer is 1.423. Okay, so part C then says, take the region R as the base of a solid and use each cross-section perpendicular to the x-axis as a rectangle whose height is 5 times the length. So to do this, and I'll find some space up here, I need the same limits of integration, which is very convenient, 0.2387 to 1, and I need the base to be the difference here between the top and bottom curve, and then I'm going to have these rectangles. Oops. Let's see if I can fix that real quick. Apparently I can't. There we go. Okay. Let's see if I can draw this better. We have this is the base, and then these rectangles are going to come up out of the base, where the height of the rectangle is 5 times the width. Okay? So I know that my base is going to be top curve, rad x, minus bottom curve, e to the negative 3x. And then I need the base times 5 times the base. So what you're going to see is that I actually could rewrite this. I have a dx here. I could rewrite it as a 5 out in front, integral of 0.2387 up to 1, and then I have the square root of x minus e to the negative 3x all squared dx. So now we're going to go back to the calculator, and let's see what we can do in the y equals screen to make this doable. I think I'm just going to put the quantity rad x minus e to the negative 3x in my parentheses, in my y1. So rad x, and then insert here minus e to the negative 3x, and then I'm squaring it. So I have a squared here. So now I have, in my y1, I have my entire integrand. So I come back to my home screen, and I'm going to do alpha f2, choice 4 for integrate, and I'm integrating from 0.2387 up to 1, and I just need in what's in y1. So vars, y-vars, function y1. Come over here and hit the dx. And then I also need to make sure I'm multiplying this whole expression by 5, because I have 5 times the height times the width, or the height is 5 times the width. So I need this constant of 5 out here. And I get my answer of 1.554.